Amazon Web Services provides many different cloud-based solutions to meet your hosting and computing needs. One of the solutions, which is Lambda, is virtually a serverless service that gives you the power to create standalone functions which can be triggered by external events like file uploads or web traffic. Hi, I'm Nadeem, a certified AWS Solutions Architect. In this video, I'm going to cover how to create a simple Lambda function in the AWS console for basic file handling in Amazon S3. So without further ado, let's get started. If you plan to follow along, the prerequisites here are pretty basic. You need some foundational knowledge of Python, like functions and loops, and access to the AWS Management Console. Before we get started, let me give you a brief overview of what the Lambda service is, so you get an idea of things you can do with it. You have probably heard that Lambda provides serverless computing, but what does that exactly mean? Obviously, there's a server running somewhere. Lambda is a service that has no administrative overheads like managing the underlying server. You simply write your functions and deploy it, and Lambda patiently waits for an event to trigger. A Lambda function is just that, a function. It's not designed to be a complete application, just a specific action that should be triggered by an external event. And as with many other AWS products, you can interact with Lambda via console or using the command line interface. There's also an API to integrate with your system if you prefer that. So, what can you do with Lambda? The possibilities are really endless, as you can take almost any application, break it down into microservices. Let me give you an example. Data processing. When data is added to a database or another system, a Lambda function can use that data to calculate other values, update the status of the specific items, say update an order, or transform the newly created data into a friendlier format. Imagine if you have a job to regularly consume data from a specific provider, but you need to reshape that data to work for your own needs. Lambda would be a great solution to that problem. File processing. With S3, one of the most common examples for Lambda is also one of the coolest one. When somebody uploads an image to an S3 bucket, a thumbnail is created and uploaded to a separate bucket. Lambda integrates seamlessly with AWS services such as S3 and can trigger a Lambda function directly. I'll shortly demonstrate how this works. Alexa is a great example of an integration where a user does something that triggers a function. This kind of integration can work with most IoT devices. A mobile application almost always needs a HTTP interface, and with API gateway, you're able to tie HTTP requests into Lambda functions. Similarly, the API gateway and Lambda can be combined to create a web application in a completely serverless environment. Now that you've got an idea about what we can do with Lambda, let's dive in and get started with this. To give you an idea of what we are about to configure, here is a diagram. This is a typical AWS architectural diagram. So a user will upload a document into our source bucket. This action will trigger a Lambda function, and our code running here will copy the document from this source bucket to the backup bucket. Sounds easy? Let's go ahead and configure this. Okay, so open a browser and log into your AWS Management Console and click on Services. What we are interested in is in Lambda, which is under Compute. We'll be looking into S3 under your storage, and IAM to create our policy for Lambda. So let's start with S3. We're going to be creating two buckets here in S3 that we'll be working with in this exercise. So S3 is a cloud storage resource of Amazon Web Services for storing objects. and it is similar to the files and folders that we use, but this one consists of data and its descriptive metadata as well. So let's start with creating a bucket. I click here on create bucket. I'll give a name which has to be unique because this name is used worldwide by other AWS users. So for this exercise, I'm going to be using the name Lambda drop bucket. The region I'm using is US East 1. Click on next. I'm not going to be using versioning, so I'll keep that unchecked. I'm not going to be logging this, so that's also unchecked. Let me give a tag over here. And then we click next. The permissions are fine. We don't need to give access to public. So we click on next. We review the settings and we click on create bucket. And I'm going to be creating another bucket with the same name, but extend that with another word called backup. So that's going to be again Lambda drop bucket backup. The settings are going to be the same. Purpose Lambda demo. Next, and create bucket. So the logic that we are going to be using here is any document that's going to be uploaded to the first bucket will trigger an event wherein Lambda will pick up that document from the bucket and copy it to the backup bucket. The next thing that we are going to do right now is create a role that's going to be interacting with Lambda as well as the S3 service. We'll go to services, we'll click on I am, and then we click on roles and we create a new role. We'll select Lambda and we'll attach two policies. One is to Lambda. We give them full access, and we also include S3 full access. We'll give ourselves a tag so we are organized. We're going to give this role a name. Let's give it S3 Lambda demo role. And we'll just include a role description here. And we click on create role. Perfect. Now let's go and explore how the Lambda dashboard looks like. Now we are on the Lambda page. Let's go ahead and create a function. We'll select a pre-configured template. So we click on blueprints. The runtime we'll be using is Python 2.7. And let's look for the blueprint that has the name S3 get object. So we select this blueprint and then we click on configure. We give this function a name. Let it be Lambda S3 demo function. And we choose the role that we had previously created. So that role will be attached attached to this function, and we'll select. Notice that the S3 is already configured here as the trigger, since we are using a blueprint, a template here. And we'll select the bucket. This is the bucket where the document would be uploaded to. The event type would include all objects. We would use prefix and suffix if the document that will be uploading would have a certain prefix or a certain suffix. So we won't be using this function right now. We'll enable this trigger. So this is the code that's going to be running. This is the Python code that is going to, once triggered, will basically go ahead and pick up the documents from the first bucket and drop it to the backup bucket. We click on create function. Alright, so the function is created. Now, before we go ahead and test it, let's explore the various functions, the various options over here on the screen. So starting from the top, the throttle button would basically reset your concurrency to 0. This is not something that we are going to be using in this exercise. This would be most likely be used when you have when you need to edit your code and there are too many concurrent connections and you would like to disconnect them. That's basically during a time of an emergency, which is not applicable to this exercise we are doing right now. And under qualifiers, you will find various versions of your code. If you're making any change to your code, you can save the versions, and that can be selected from qualifiers. Under actions, you can go ahead and publish a new version of this code. You can have as many versions as you want. Notice that it won't allow you to create a new version unless you've made a change to the code. You can create aliases for your code, and you can select those from the qualifiers. You can also delete the function, export the function into a file into an S3 bucket, and you can also deploy the function on CloudFront Edge at the entry point of a request. And you'll use test to test this function. Coming down, you'll see monitoring here, which will not be very interesting right now because we don't have any function running. Going back to configuration, under designer, you can select various triggers. In our case, S3 is already selected here, so we are not going to be adding any other triggers. Here you can select the entry point of your code, which in our case is already selected from the template, which are loaded from the template. You can either upload a zip file or from our file from an S3 bucket. Our runtime can be selected from here. In our case, we are going to continue using 2.7 Python. The handler will essentially be the function that will be created in your Lambda code. So this is again configurable. You can change the name if you wanted to. And this is where you basically go ahead and edit your Python code. You can add any environment variable over here that can be used in the code. Any additional tags if you would like to. The execution role has already been selected when we configured the function previously. So that's going to be using the Lambda demo role that we created. You can also configure memory and the timeout over here. So the higher the amount of memory, the more the cost would be. Similarly, the higher the timeout duration would be, the higher the cost can get. Here you can select a VPC in case if you are accessing a resource inside a VPC, which is not the case for us right now. You can also enable debugging here, and you can send those messages out using the simple queue service, or notifications using SNS. You can also configure the concurrency over here. We are not going to be reserving any concurrency. This also would incur cost. For auditing, we're going to be using CloudTrail if that is required. So before we started our test, to check the connectivity, the configuration that Lambda is able to access the S3 bucket, we will go ahead and upload a document first. So we'll just upload a text document here. Right. The document is uploaded, and now we'll go back to our Lambda function. Select the function we just created, and then we click on test, which will bring a pop-up which is already got a template pre-selected. This template is coming from the blueprints that we had previously selected. So this template essentially is going to access the bucket and get the metadata of the object that we have just uploaded, which is a text file. We'll have to just make a couple of changes here in this bucket, so we are able to run this test. First, we'll configure the object's key value, which is the name of the object. That's gmat scores.txt, and then we'll also include the ARN of the bucket, which is lambda drop bucket. We'll also have to specify this under the bucket's name, and we give this event a name, lambda test event. We go ahead and create the event. So the event is created. Now we'll go ahead and test it, and if it successfully runs, then we should be able to get the metadata of the object that we've just uploaded. Let's click on test. Great. So the execution has succeeded. As you can see, it's returning the value of text plain in the metadata, and it also displays the other output, which is the build duration, the memory size that was used, the total memory size that was used. So perfect. So we have run our initial test, and now we can go ahead and make the changes in our actual code so that we can start picking up the objects from the first bucket and drop them into the backup bucket. So unlike the test code that we ran, our real code is going to pick up the object from one bucket and place it in the other bucket. The Python library that we are using is called Boto3, which wraps interaction with Amazon Web Services. Specifically, we are using the S3 functionality of this library. By default, the handler that Lambda uses is called Lambda handler. Now in the handler, we are doing a few different things. First, we are going to grab the bucket name and the path to this in the object included here. Next, we get the key or file name for the object that the event specifies. Finally, we retrieve the object from S3 using the bucket and the key we just sent. The content type is printed to the console, and then the function returns the content type. Whatever value is returned by the Lambda function will be printed in the result pane, while the result is printed here in the execution result pane. items logged to the console are shown in the logging pane. Here we have the content type string from the code along with some other debugging information about the request and response. First, we need to define a backup bucket, which should just be backup hyphen bucket hyphen backup. So we just do bucket equals bucket plus hyphen backup. Remember, that's the name we gave for our backup bucket. And now we're going to do the copy itself, saving the response to check for errors. So this is going to be backup response, and instead of get, we do copy object, saving the file into the backup bucket. Copy source being the original bucket. And the file being the original file. Okay. Now let's add some code to give a response back. If backup response, that is response metadata and HTTP status code equals 200, return successfully copied file to bucket name, and that would be key comma backup. Else return unable to copy file name to bucket name, and also let's give back the code, the response code. That would be key comma backup comma response comma backup response. I'm sorry. Alright, so we don't need to give back the response. Now we don't need to print this previous response and content type. We'll just take them off. Okay, so we are done. Let's save this code and run it, and let's see what happens. So let's save and test it. Okay, so there's an error in the code at line 21. Okay, we forgot to add a colon here. Let's save it again. Test it again. Okay, there's another error at line number 29. Backup is not defined. Oh, okay. Here you are. That's the problem. Okay. The third run. Let's see this time. We save it again. And we do our test. Let's go up. Great. We've successfully copied gmat scores.txt to Lambda drop bucket backup. Let's go check it out. We go to S3. And then let's go into our backup bucket. Okay, so this file wasn't here before, so it's got copied. That means our Lambda function is working as expected. Let's do this. Let's copy another document. Let's copy another file, and let's see if the Lambda function picks up any new files that's uploaded. We'll just rename this old document. We'll copy this, or we'll just rename it. Gmat scores -2, and let's upload this file this time. Upload. It's uploaded now. Now let's go back into our backup bucket and let's check it out. It's not here. Let's refresh. There you go. So our Lambda function is now working perfectly. Similarly, we can use this mechanism and add some code to process a document in transit, like resizing an image before copying it to another bucket. Great. So hope you find this video useful. Thanks for watching and stay tuned for more videos. Goodbye.